For this type of problem, we're plugging in the same value for m into two different expressions. Here's one, here's the next. And it's just to illustrate that the two expressions are equal to each other because we should get the same value for each of them whenever we plug in the same number for m. So in the first one, everywhere I see an m, I'm going to replace it with a -2. And I like to put parentheses around my number I'm inserting anytime it is a negative number. So that way I don't confuse it for a subtraction sign or mess up anywhere. So I've put a -2 in there for m. Order of operations, I'm going to work within the parentheses first and reduce those down to a single number. So 9 times a -2 is -18, and I'm adding 1 to that, so it's going to be -17. The tricky part with these is making sure you get all the negatives, additions, and subtractions correctly. So pay close attention, double check on the calculator with all of those. So 2 times a -2, -4. Adding a +7 to that, I will have a +3. The parentheses are now both single numbers, so I can move on to multiplication and division with the order of operations. I have one multiplication to do here. I'll get -34, and nothing to do with my 3, so I'll just leave that alone. And if I was -34 and I go -3 more, I'll get a final result of -37. So plugging -2 in to that first expression gave me a -37. I should get the same exact result plugging it into the second expression. That's the goal, is to show that they are equal. So on the second expression, 2 times 9 times our m, which is -2, plus 2 times 1 minus 2 times -2 minus 7. So doing this, the parentheses are all a single number, so nothing to do inside of them. I can move on to multiplication. So 2 times 9 is 18. I'm just moving left to right with my multiplication. 2 times 9 is 18. Times 2 more would be 36, and it's negative, so -36 plus 2 times 1 would just be 2. And then minus 2 times -2 would be a minus -4. So instead of, I could write here minus -4, I'm going to change that to a +4. Minusing the negative is the same as addition. So I had a choice there, and I just like to write the plus when it's a minus and negative. And then -7. So now I'm ready for addition and subtraction. Again, just going to move left to right with the order of operations. So I was -36. If I add 2 to that, I would be at -34. I'm just keeping track up here. If I add 4 to that, I would then move to -30. So getting less and less negative as I add positive values to that. And then I'm -7. So was -30, -7 more puts me at -37 for the result. And so we see that they both expressions are equal to -37, so they are equal. Simplifying this here with the distributive property, I need to multiply the value on the outside by both of the values on the inside. That's what it means to distribute. We're spreading out that 5, that multiplied by 5, to both terms on the inside. And so one at a time, if I do 5 times 1/6a, just do it with fraction multiplication. So 5 times 1/6 times a, 1/6a. Well, fraction multiplication, if it is a whole number like this, we do 5/1. That's how you would write it as a fraction. And then you just do top times top and bottom times bottom. So 5 times 1 gives me 5. 1 times 6 gives me 6. And so now I have 5/6a. And the a remains unchanged. Any variable like this with a coefficient with a number in front of it If it's multiplied by another number, we just multiply the numbers together and get a new coefficient, a new number in front of the variable. And our second part of the distribution is do the 5 times the second number. So again, as a fraction, it's 5 over 1 times 5/7. Top times top gives me 25. Bottom times bottom gives me 7. And so my final result is right there. So that those two terms, the 5 times the first term plus 5 times the second term. For this problem, we're asked to simplify. We're going to reduce it as low as we can, basically do all of the operations and try to combine the numbers. Order of operations, I need to do multiplication and division from left to right before I do the addition. So the first division, 20 divided by 5 gives me 4. And then the multiplication gives me 27, 3 times 9. So now that I've done the division and multiplication from left to right, now I can do the addition and subtraction operations that remain. There's just one. 4 plus 27 gives me 31 for the solution. For this one, similar to the first problem in the video, I'm plugging in a value for b. I'm plugging it into two separate expressions, hoping to get the same result to show that there's equality here, that both expressions are equal. So in the first one, 15 times 1/3 plus 4/9, and I'm plugging in a 3 for b. I need to start with parentheses and reduce those down to a single number. So 4/9 times 3, I'm going to write 3 as a fraction to make that easier to compute. So 4 times 3 is 12, 9 times 1 is 9, top times top, bottom times bottom. Within the parentheses, there's now one operation left to do, and that's the addition. So I did the multiplication first. Now I'm going to do the addition. I have to have the same number on top and bottom, the same number on bottom in order to add fractions. I need a common denominator. So 1/3, to change that 3 to a 9, I need to multiply it by 3. And I need to multiply on top and bottom by the same value. So if I multiply on bottom by 3, I multiply on top by 3. So I get 3/9. And here I have 12/9. So now I can combine those. I'm switching colors here just so it's less confusion. It doesn't get mixed in with what I wrote earlier. So I can add the numerators together and get 15/9 since I have a common denominator. And now that I've reduced that inner part to just a single value, I can go ahead and multiply, do this multiplication. Now I could go straight away and do 15 times 15 and on bottom 9 times 9. I'm going to choose to do a little reducing now ahead of time before I do the multiplication and then reduce afterwards. So this fraction doesn't reduce any, 15 over 1, but this one will. I can divide on top and bottom by 3. And so I am going to do that. I'm going to divide on top by 3 and get a 5, and on bottom by 3, divide on bottom by 3 and get a 3. So now I have smaller numbers to work with. It's going to just make it easier to do the multiplication. So 15 times 5 is 75. 1 times 3 is 3. 75 divided by 3, this fraction, 75 over 3, reduces to 25. So that is my final solution from plugging in a 3 to this right there. And so now I need to plug a 3 into the second expression, and we're hoping to get a 25 as well. So 15 times 1/3 plus 15 times 4 over 9 times a 3 now. Before I do addition or subtraction, I would need to do all the multiplications first, so I'm going to do that. 15 times a third is 5. And so I'm just doing them left to right. Now 15 times 4/9. Let's go ahead and work this out here. So 15 over 1 times 4 over 9. Top times top would give me 60. And bottom times bottom gives me 9. And so I've done those. I'm crossing them out. And I still need to do multiplied by 3. So multiply by 3 over 1. Now I could dive straight in and do this and then reduce afterwards. And I would rather try to reduce ahead of time. So I'm going to divide top and bottom here by 3 and get 20 over 3 times 3 over 1 still. So I can't reduce the 3 over 1, but I can reduce that first fraction to 20 over 3. So now multiplying top times top, sorry, this is getting a little crowded here. 20 times 3 is 60, and 3 times 1 is 3. 60 over 3, 60 divided by 3 gives me the result, coming up here at the top to write it, of 20. So this multiplication here of these three things together comes out to 20. And it's a good idea to do it by hand, but then also check it on a calculator, use Excel, use Google, use something to confirm, double check your calculations when you're doing complex things here with fractions and common denominators and reducing. Just make sure you didn't make a mistake. So now that I have done all the multiplication, I can do the addition. 5 plus 20 gives me the result of 25, which was what I got for the other expression as well. So yes, they are equal.